Let's begin our review of forces. A force is a push or a pull, an action that has the ability to change the motion of an object. When we've discussed motion in class, we've discussed motion as having two components, speed and direction. The three forces that we have focused on have been gravity, which is the force of Earth pulling down on us, friction, which is the resistance of objects to motion, and normal forces, the forces pushing up on objects. Now let's consider a person trying to push a box across a surface. The person in this example is pushing with a force on the box, having it slide across the floor. Sliding friction is slowing the box down, but is not strong enough to stop the box from moving. So let's look what happens when he gets the box to a rough surface. The box no longer slides when the box reaches the rougher surface due to static friction. Think back to the experiment that you conducted in class involving sliding of wood blocks across different surfaces. Those of you that tested sandpaper, when your box tried to slide across sandpaper, the rough surface did not allow it to slide very easily. More force was needed. Now that we've gotten to the point of having an idea of objects being able to move or objects being stopped, we need to consider balanced forces, unbalanced forces, and the idea of a net force. A balanced force, or pair of balanced forces, is when you have two forces acting in opposite directions that are equal to one another. Unbalanced forces would be those forces acting in opposite directions of one another, where one force happens to be greater than the other. When we then look at the idea of a net force, in our first example, we have 5 newtons to the right and we have 5 newtons to the left. This results in a net force of 0 newtons. When we look at the second example of an unbalanced force, and we have 5 newtons to the right, or positive 5, and we have 10 newtons to the left, or negative 10, our result is negative 5 newtons, or 5 Newton force pushing to the left. So we get this idea that motion can change only through the action of a force. Let's take two people playing baseball. As long as that baseball sits on the grass and nobody touches it, no wind blows it, that baseball will stay there forever. Once a boy or a girl comes to pick that baseball up and begin to have a catch, that baseball will be thrown due to a force supplied by the girl or the boy's hand throwing it. That baseball will start to move. However, as soon as it is released from the person's hand, there's no more force acting on the baseball to keep it moving forward. Instead, we now have gravity pulling down on it with no normal force of the air holding up on it. We have air resistance pushing against the ball, slowing it down. Therefore, motion, which we have said would be speed and direction, the motion of the ball will change. That ball will begin to slow down and it will begin to go back towards Earth's surface. Now what we need to remember about that example is that there are forces that are acting on that baseball to change its motion. There was a force of air resistance, there was a force of gravity. Let's take a space shuttle out in space. It's in a microgravity environment. The space shuttle has already launched itself and is moving forward from the thrust of its engines. Because it now gets to a point where it is far enough away from Earth, again, let's talk about when man finally goes to Mars, that Earth's gravitational pull is not going to be strong enough to pull it backwards, so that object will continue to move. And there's so little air in space that there is no air resistance. So this space shuttle will continue to move at a constant speed in a straight line forever unless it gets close enough to another object whose gravitational pull begins to change its path. In class, we rephrase this idea of constant speed in straight line to say constant velocity. This brings us to Newton's first law that states objects at rest remain at rest and objects in motion remain in motion with a constant velocity unless they are acted upon by an unbalanced force. This brought us to another term called inertia. Inertia is the resistance of an object to a change in motion. We connected resistance directly to mass. And we came up with the ideas that the greater the mass an object has, the greater its inertia. In other words, the greater the mass an object has, the more difficult it will be to move that object. Think about the last time you tried sliding a chair across a floor versus sliding your dresser across the floor. The dresser had greater mass, so it was more difficult. Let's look at this with the automobile accident that we've been investigating. We had two cars. Car 1 that was moving in this direction. We had car 2 that was at a stop perpendicular to car 1. When car 1 reached car 2 and made contact, car 2 moved to here. Both cars had inertia going into this accident. Car 1 had the inertia that was moving it forward that did not want to allow the car to come to a stop. Car 2 had the inertia that wanted it to stay exactly where it was and not move. When car 1 hit car 2 moved a good distance. What we've been able to figure from that then is that car 2 must have had a lower mass because it was not very difficult for car 2 to move a great distance. Low mass, low resistance. Car 1, on the other hand, seemed to have not moved very far until we investigated just a little bit further and we realized that car 2 continued to move even after impact. Looking at the crime scene, we noted that there were skid marks that went from here to here. Friction came into play to slow the speed of the car, and the impact itself, the force supplied by car 2 against car number 1, helped to slow car number 1 down. We're going to continue to look at Newton's laws. We're going to continue to review forces, but you need to make sure that you go back into your notes, you go back into your textbook, and you ask questions in class.